Hello, Alexis. How you
Ciao,
doing?
Stefano. So we're going to talk about recursive language models today, and I have to confess I do not
I
fully
think we missed
understand
your
them yet.
voice for the very beginning a little bit.
What? Okay, can you hear me now?
Yeah. Really, I
Okay,
think.
so I was saying today we're going to talk about recursive language models because
Oh my God.
they're super hot right now, and there's been a number of shares that are about recursive language models and about reading the recursive language models paper. And I want to get to those, but I should confess right away, I don't understand them yet. And I think it would be good before we look at how you can use Solve It to implement one, if I just harass you with specific questions about what they are, because I think that will be a good framing for a next episode. Are you able to tolerate that?
I'll do my best. So let's jump
Okay.
into like the clickbait of current AI.
Yeah, there
Okay.
we go.
So,
So,
yeah.
so here I'll tell you what I understood from reading this quickly, not going into full depth on it. And then and then I'll ask some questions to clarify, and you can like help me see
Yeah,
if I'm confused.
you read the blog post, right? This is the original blog post from
Yeah.
15 October. So yeah,
Yeah. So in this post, they highlight a few terms: query, root language model, environment, and context. Um, and the root language model is like a master model that interacts with the environment. And from that environment, or maybe alongside that environment, it can send queries to other language models. True or false? Is this correct?
correct.
Okay. Um, so this isn't about training or architecture. It's really a inference setup. It's a inference
Strategy.
harness or strategy. Right. Okay. And the point of this inference strategy is to get better performance from this system than you would get just from having one model sitting there on its own. Correct?
Yeah, this is the core idea. And like,
Okay. And in particular, what they talk about is uh, getting good performance even in the face of a large fraction of context being full. It's to mitigate context rot. Yeah.
absolutely. Because
Context rot's the familiar thing where you're talking to a language model, say Claude Code, and when you're like 80% in, it's like the guy's drunk and you're like, come on, pull it together. Right.
exactly. It's not the same kind of performance you have at the beginning of your conversation. And I
Right.
think everybody in this audience experienced this with like Cloud Code, but even like standard language model like ChatGPT, everything is
Sure.
the same
Sure. I
story.
think this is a familiar experience to anyone who works with these things.
Yeah.
Okay. So all of that makes sense. Now, here are some things that I already know what they are. And what I'm trying to figure out is these things that I already know what they are. Is this paper just describing those things with fancy new words, or is this paper describing something new? So we can play that game now. So one
Yeah.
thing that I already know what it is a subagent or a call to another language model. I'll give you a
Yes.
really modest example. I'll be using an LLM to work on a website, and then I want to see if a screenshot of the site has correct layout. Now, I don't want the LLM I'm talking to burn up its context by consuming the bitmap image. So what I'll do is I'll create a command line script and I'll tell the LLM, hey, you can use this script to get a summary of the image. And then the LLM uses that command line script, and that script actually goes and it calls Gemini. It calls a second LLM. So, you know,
Yeah, we're doing this since a lot of time,
right,
right?
that's been
We
around a long time.
delegate
So so
something
so 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 if you
to
wanted
another
to
language
if you want to
model,
put a
another
five right,
agent.
yeah, if you want to put a $5 word on it, you could say I'm using a subagent to mitigate
Yeah.
context rot. But that doesn't seem like I wouldn't write I wouldn't write an archive paper about that. So presumably that's not what they're talking about here,
No.
or
It,
not
it,
merely that.
there is that thing happening, but it's not the point that they're making and like the
Okay.
reason why they're doing this.
Okay, so
So
that's not the point they're making. Let me suggest another thing. So I'll be working with an LLM as you do. Um, and then I realize that I'm burning up a lot of context, and I'm worried that in a later session or after compaction, the LLM might be confused. So I'll say, hey, friend, could you just write down in a markdown file the things that you're going to want to remember for later? And then it does. And then later it reads the file. And I find that that helps. So really, I'm just saving and reading from a file. But if I wanted to put a $5 word on it, I could say, well, I've implemented a memory system it has a scratch pad that's separate from the context because that's on the file system and it's not in memory. But I wouldn't publish a PDF about that, right? So I guess one question is that's not what they're talking about, right? They're not just talking about that.
We will see this later, and we hear from the word of like Alex Zhang is one and the main author. Like he discussed
Okay.
about this in late October in a presentation when he was presenting his blog post before the paper. So there would be something happening. But it's interesting that you said context compaction. So
Right.
you understand that there is the need sometime when the context grows to compact it, not only because you risk to get out of the maximum size the language can deal with, but even because you know that if you don't
Yeah,
compact it,
sure.
it's going to start work in a bad way. So this core idea of having a way to let the system deal by itself with context compaction instead of you telling the system slash compact or trying to acting helping the model to solve the problem. Like the idea they're trying to
Okay.
propose is a
Okay.
is a trying to say we want to set up the thing such as I give the language model a problem, a general problem, and the language model has the ability to manipulate his own context in his own
Hmm.
way. We provide all the tools to do that. And the main model, the root model, will spin up submodel or subroot models. It's the recurrent thing is that you can spin up multiple instances of this concept and at the end, finding a way to manipulate your context and give an answer. But the key point here is that the main model is never looking at the whole context at the same time. Is inventing some code in this sample or some actions in the whole context that is stored in memory or in a file, no matter,
Hmm.
to manipulate this big thing and focusing on where it thinks it's the solution. We're gonna see this later. So let me
Okay, so
I don't want
that
to
that
spoil too
strikes me as
much
a
about
that
this, but
strikes me as a suspiciously long answer, right? Because it sounds like you're saying part of what the paper is talking about is kind of what you just do with a markdown file. Part of what the paper is talking about is kind of just what I do if I create a subagent to process an image. But then but a thing that you said that I comprehend is, okay, well, I'm just, relying on compaction as some like magic step that Claude Code implements. But maybe what they're talking about is like under the rubric of what's a clever way to do compaction or what's the right way to do
yeah.
compaction. Um, and
And by the way, Omer Khattab wrote some original paper on different strategy to make concept compaction a couple of years
mhm,
ago, I think. And it's a thing that is around like being able to deal with big contexts, like especially in the past. Remember, we have like a very few like a window to deal with token. It was a very important like to have compaction. Now
mhm.
it's less, but we're throwing more and more data at it, so it's gonna be important. And
Okay,
so let me like try to literally explaining the thing because I want to have the audience to be
okay,
sort of or the same page as ours,
okay.
at least with the ideas, and
So I
then
have a rough idea now of what it's not merely. And now you can tell me, what
yeah,
it
yeah,
is beyond the things that it's, not merely being. It's not merely a call to a subagent. It's not merely a storage system outside of
no,
context. It's not merely, say, automatic summarization as in compaction. It's also, okay, give it to me. What is it?
it's also letting the model explore and find the best solution instead of trying to like mm, decide on our side beforehand what is the way to solve a problem. Let's leave the model free to experiment. That's the idea. Like Alex says a lot of time in his like interviews, let's say like we don't want to constrain the model like removing ability to do something. And so, yeah, let me try like to go a little bit deeper with like this introduction. And so again, I want to say that everything started as a blog post. Like the very first thing that comes out like in middle October with like this blog post that you were reading. And where they clearly state that the goal of this is that trying to find an inference strategy to let us deal with like context rock, even for language model have the claim to have a big context the context window. So again, it's interesting in the blog post they really frame like give it a formal definition I like the idea that they try to frame this as a language model. They actually create this strategy that is a wrapper of a language model, but has the same API of a language model. So a classical language model is the outcome, the output of the language model is a function of the context and the query. Actually, like the query and the context is the same thing. Alex says this in an interview, but we just separate them for the sake of like simplify this thing.
Sure.
Because in a typical language model, you concatenate the context, that is everything before your question, and it's a function, the result's a function of these. Here you have the query, okay, that goes to the main language model. This is the core idea. You make your request to the main language model, the root language model, and you provide the context not to the main language model, but to the environment, say the REPL, the shell, where the language model has the ability to write code. So you provide the context as a variable, like the variable context, literally, in this environment. And you tell the language model, you need to have a little bit of a prompt. We will see an implementation. You have the ability to explore with Python the variable query that contains all the information. And this information can be like a million, 2 million, whatever token you want. And the language model is not looking at all of these like we used to do, like function means like given to the language model. It's trying to say, okay, what can I do? For example, an interesting thing that they always define is the length. So the language model as the first thing is I try to compute, oh, what is the length of this context? So maybe if the length is small, I just make it a request, I'm going to go. So it's trying to understand what is the problem that I'm doing. So if the query is not something, if the context is like code, is like the print version of like the folder containing a bunch of file one after the other, and you make a request in terms of what is this function define or what explaining what this thing do, is it probably do something like load code. But if the context is, for example, I don't know, an enormous CSV file or three different CSV file dumped into this as a pure text because just the people put the things there, and you say, okay, can you transform these CSV files into three different, like, I don't know, join them into a table and give me back all the row align. Probably you're gonna see the system writing down pandas code. First of all, finding a way to split the context, then writing some pandas code that bring that part of the context, create a data frame, create a second data frame, make the merge, and then give you back the thing. So it's completely free to manipulate this enormous chunk of text as the context in a completely free way. And not only manipulate as like a root language model, but it can even ask to another language model. It's just a function that can make a comment or make more code, or as you said, it can delegate to a sub completely architecture like this, that the first element is just the data of the CSV. Oh, I give it to you, and the second one nested receive the CSV context and the query that says maybe transform this into a pandas data frame and save it as pickle.
Yeah.
I don't know. So it's completely like going in his way. It's a free code agent. The first time I look at this thing, I was thinking, oh, this is just like code interpreter. But I realized the code interpreter is not able to call another language model and spinning up another code interpreter and going deeper into the rabbit hole. So like, okay, let me like start framing these. I hope that you have a better understanding of what you can do with this and how this is so general instead of being so specific to the code. Okay.
Yeah. So, okay. So I look forward to our next episode going into this, but let me give you some quick reactions off the top of my head.
I still not
And
finished, by the way.
what?
I still not finished with the introduction. I got the
Well,
few more
okay, but
slides.
we're out of time now, aren't we? So you're not going to get through the rest. Um, okay. So what you said kind of translates to I've rigged up a language model so that instead of it just having its input context and it's spitting out text, I've given it tools, and the tool is access to a Python REPL. And the input that it's processing is available to the language model as a variable within the Python REPL. So now the language model doesn't just need to like think about it with its own brain, it can exploit the Python, language prompt to do things with it. And you've
Yeah.
also, so that's one concept, which is don't have the language model process text directly, have it use a full programming language to drive manipulations of context, like searching things or, computing or whatever. That's one concept. Second concept is like, oh, by the way, it can also call other models. All right, fine. That's just an extension of the idea that you're giving it a programming language. Now it can
It
use that
is.
programming language to call subagents. Now it can use it to book a flight to Mexico. It can do whatever it wants. That's a kind of logically separate and orthogonal concept. I get it. Um, and yeah, that sounds like that's useful. But I have a reply to that. Can I share my screen? Is that possible? Can we do that, or is that too complicated?
Yeah. Let
I'll send you a URL. I'll send you a URL, and then you can see if you can display this URL. Okay. Is that okay?
okay.
I think we have the technology. It's 2026. All right.
Yeah. Let
Incoming
me,
URL. It's on
can I
image
just
flow.
like, 1 second, gonna like a little bit quick to, okay, you already sent it. There we go. Oh, okay. Let's see what's gonna happen here. So here, there we go. Do not consent.
Yeah.
Okay.
Okay. So this is what I think. Corporate needs you to find the difference between this picture and that picture. I refuse to play along. It's the same picture. Okay, on one side, you have a shell interpreter prompt called bash,
Yeah,
where Claude Code can write commands. And on the other side, you have a
absolutely.
Python,
The most
and on the
general
other side,
possible.
you have a
Yeah,
Python interpreter prompt, where instead of writing like dir to find out what, to writing ls to find out what the commands are, I write dir to find out what the functions are. It's the same picture, okay? Like your brain needs to be like too far in the details not to see that like one interpreter is not qualitatively different from another interpreter. So my first reaction to this idea is like, sounds great. Sounds like it already exists. It sounds like that's kind of what you're doing if you're doing anything interesting with Claude Code. Claude Code already has access to the shell and it can already create programs on the fly. And it
yeah,
does by piping commands together and it runs them on the shell. And if you gave it a huge, big, complicated file to think about, then you wouldn't ask it to think about it on its own. You'd say, hey, can you find all the instances of, this string in this gigantic file? And it would be a little smart guy and it would use grep to do it. So
yeah,
um, I think I look forward to like, studying this paper in more detail and seeing the implementation in more detail. But what I hear so far is that this is an attempt to formalize in an
yes.
abstract way
That's one of the value.
something that's already happening,
Yes,
and some of these and some of the um, way in which this is slightly hard to understand and is presented very abstractly is everyone trying to get to the essence of what's actually happening. But if you like put on your galaxy brain hat, you know, and like look at the essence of what's already happening. It's not a new thing, it's a thing that's already happening there. So it's just a perspective. And if you just keep in mind that shell interpreter prompt and language interpreter prompt are not morally different things at all, then you can kind of perceive that like they're the same picture. That's my first reaction, but
yeah,
this is
okay.
like not fully informed.
Seriously, thinking that reading it for the first time, they say, "Oh, this is just Cloud Code." I got the same kind of feeling the first time I read it. But from another point of view, I say it's really valuable to frame the way they're framing the problem in a general way to let you think at the broader picture like they do. But at the end of the day, what I was doing, like I want to just presenting you that this is like, okay, these were the previous slides were the original blog post. This is the presentation that main author of the blog post and in the paper too made at the end of October. And at the minute 34, he's talking about like the difference because everybody, when he presented this blog post, everybody in Twitter say, okay, the same question that you and me had, like, what's the difference? And at the end of the day, like, it goes straight to this link, and we're gonna make all this available.
What's they saying here? Claude Code is designed for code. That's nonsense. You
It,
can use it for any text files.
wait,
You can
wait,
use it for
it,
anything on the file system. Anyway, we'll have
yes,
to
yes, it is.
we'll save
It
this for
is.
the next episode. We'll save this for the
Alexis,
next
yes,
episode.
all of
Yeah.
this. Are you saying it is? and
Right.
he even say the same thing on the interview. And at the end of the day, quoting his word, like that this system has a very specialized instantiation of the RLM abstraction. Is trying to find a way to like abstract the idea behind the cloud code, okay, and trying to make it more general. And I think that is a value in trying to uh,
Yeah, no, I
organize. Like,
agree. I
think
agree.
about like a design pattern. Like design pattern before the Gang of Four, they was around. Just these guys give a name to this. Like, okay, this is a design pattern. This is something like this, and it's no more like this agent, sub agent. Like, what are you doing with that? I like the way they're
So
framing the problem.
I buy that, and I enjoy abstractions. Otherwise, I wouldn't be, I wouldn't have ready in my back pocket an image flip saying shell interpreter prompt and language interpreter prompt are the same thing. I have that because I've had this thought
We
before and
got
have
it. We
been
got it. I
frustrated by
agree with
people
you.
not seeing this before. Um, and I guess I'm just a little confused when the abstract says we propose RLMs an inference strategy, da 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 da, where it's more like describing a pattern that already exists. Like Gang of Four didn't, you know,
I know.
declare they were inventing something. They just said that we are kind of summarizing and stylizing existing patterns. Anyway, I don't want to sound critical. I'm
I,
just trying to, get into it.
I got an argument responding to this question too because it's the next slide. This is like
Okay.
okay, wait, this is the beginning of the paper, and
Hmm.
I bring it because like yeah, the paper comes like at the very end of 2025 December,
Right.
and I just want to point out like is a big deal. Aside who invented, I don't want to get into this thing. I just like dealing with context rock is a big deal. If we have a pattern, a strategy, or whatever that can help us dealing with huge context, if we have like an approach to deal with big context is important. And as we can see here, the simple GPT-5 that has about like
Yeah, no, I get it.
260,
Agreed. I mean,
like
I think we can, that
yeah,
goes
and then
without
like when
saying.
they're presenting to the audience the idea that the context route, like the same kind of problem when you're doing single needle in the eye stack, finding a single thing, it's very good until the
Yeah, no,
GPT-5
I
at
agree. But
260,000.
but
When you
I
make
think this
like
is,
a problem that needs a lot of context to make the response, the bigger is the problem, the worse is the response. And if you wrap GPT-5 into like an RLM strategy, if you use
right.
GPT-5 with a trick with the RLM, let's make like that, yeah, quality is high. You can do single needle in the high stack in a million contact or even more. And this is a big deal. And no matter the name or who invented, this thing is a big deal. And I want to understand more and more about this. And I think it's interesting. And the other slide I want to present it, like this is the
Well,
thing.
what time are we at before we go to the next slide? I demand that
We
you
have
tell
we
me
have we have a
how
few
much
minutes.
time.
We have I'm cheating. We have a few
How many
minutes.
times has it been?
Now I just let
I
me
gotta
like
go. Sorry, I have a call coming up, so I think we have to finish this one next
one
time.
minute. We getting 1 minute. So
Okay, one
the
minute.
guy at Prime Intellect, they quoting the interesting stuff that they say they like the way they frame the problem because it's a simple way of framing it. It's not like adding a lot of dedicated stuff. The general and the simple thing is an interesting idea. And even like Prime Intellect blog, it's an interesting one about RLM. They tested a lot this. And at the end of the day, what I want to say is that we got a lot of people in the Solvit community that posted a lot of dialogues. Okay. And starting from the next episode, I will like review the Marius one and then some of the others. Okay. Even
Yeah,
like I
no, I
remember I
think
was
it's good.
present like when Nate made a live session about implementing, reviewing Marius note the dialogue and implementing some thing into Solvit. Okay.
I look forward to it. I look forward to it. In my mind, this still falls under the category of figuring out what we've already been doing and having a better vocabulary for it. But right now, I gotta go. Another call.
It is a specialized implementation according Alex. So yeah.
All
Okay.
right.
Good. Bye,
Till part
Alexis.
two. Bye bye.
Bye. Bye. Bye.